June 2023, 32 variant, and question number 8, topic is differential equations. So first of all, as you know, when you deal this kind of question, so 4 steps are required. First is separation of the variables. Number 2, integration both sides. And last third number, find C value. And last number, we have to make a subject. He mentioned the question y in terms of x. So make y subject. So these 4 steps we have to do for the part number A. So let's try to do it. So first of all, make sure dx and dy cannot be in denominator. So dx multiplied there. So I can say dy is equals to 4 plus 9 y square over e to power 2x plus 1 into dx. But problem is that because y is my subject, I'll bring this completely right side here down. So I got a 1 over 4 plus 9y square dy. And this exponential can bring it up because it's a compulsory negative 2x, negative 1 dx. So separation of variable is completely done. So first step is over. So now I'm going to integrate. Integrating, so I'm just integrating. So I'm doing same step here, same time. Now, student, very interesting part. This is not a hard to do. This is a little bit difficult. I tell you, basic formula is what? Whenever 1 over a square plus x square dx. So this answer is 1 over a into tan inverse x by a plus c. But is only applicable if x square coefficient is plus 1. Okay, so I repeat my words. So x square coefficient is plus 1. Let me write the rule. Okay, so x square coefficient is equals to 1. This is a very important criteria. So check it. Do we have a 1 here available? No. And one more thing. If I take for example, 2a plus b, 2 common out. If 2 available is, okay, it's 2 alone. Now a left alone. But it's 2 available in b beside of b? No. So 2 will go in denominator. Repeat my words. If 2 common out, this 2 alone, but this 2 will go under b. So same story, I'm going to take a common out here. So when I take common out, so have a look, students. What is a method to do common out? 9 common out. If I take common out 9, so 4 over 9 and plus y square. There's a very important step. Okay, this is as simple as it is, no change. Now I'm going to simplify first of all. 9 will go outside, 1 over 9. Integral sign 1 over square of 2 and square of 3, and here square of y. Now we are ready to apply the rule of integration. Okay, and right hand side we will also integrate. This is a very easy, you know it very well. So 1 by 9 as it is, and basically, so 1 over constant. What's the rule? This a comes a denominator. So same here, 1 over constant. So 1 over 2 by 3 into tan inverse variable over, because x by a. So here y by 2 by 3. So make sure 2 by 3 in fraction form equals, what is this? First you copy as it is and divided by negative 2 because power derivative is coming down, and plus c. So this is 3, 3s are 9, 3 to the 6. I get a 1 over 6 and tan inverse, and you know this will flip up, it will come up. So it becomes what? 3y over 2. So this part is very clear, is equals to negative. Okay, this I'm keeping as it is. Negative 1, negative e to power negative 2x minus 1 over 2 plus c. Now I'm going to plug in the values which given by him. Y0, x1, y0, x1, y0, x1. So when I plug in 0 here, and tan inverse of 0 is 0. When I plug in 1 here, so I get what here? Basically, I get a 2 ones a 2, negative 3. I get a negative 3 by 2 plus c. And c value finally I got e to power negative 3 by 2. And now I'm going to plug in this value here. So check it, 1 over 6 tan inverse 3y over 2 and negative e to power negative 2x minus 1 by 2 and plus e to power negative 3 over 2. Okay, student, this is done. Let me check once again. Okay, clear. So what is a method further, how to make a y subject? Because basically our plan is to make y subject. C value, we got it. So multiply by 6 throughout whole equation. So I get a tan inverse 3y over 2. And when I multiply 6 here, so I get what, students? So negative 3 e to power negative 2x negative 1. And here same story, 3 e to power negative 3. Okay. Now basically we have to make y sub. So this tan inverse will go there and inverse will eliminate. How? You know very well, when tan inverse x equal to 2. So tan inverse goes there. So inverse will convert normal. So the same story here. So 3y over 2 and tan will go there and is a positive value and this negative. So I'm writing the order change only. So 3 e to power negative 3 minus 3 e to power negative 2x negative 1. So alhamdulillah rabbil alamin. Now this will multiply there and finally I will get the subject. So 2 by 3 into tan e to power 3 e to power negative 3 and here we can say okay, because later on we have to talk about the infinity concept. So if I bring in denominator, there's a better approach. If you don't bring in denominator, even no problem. So I bring in denominator, this become positive power. And same story here, 3 over, I get e to power, when it goes up, power sign changes. Both negative convert to both positive. Okay, now I think so this part is clear. And he said make y subject. And let me check finally. Yes. So this target is achieved. Last part of the question. He said when what happens to value of the y when x tends to infinity? And an exact form we're looking for. When x tends to infinity, I'm going to plug in x tend to infinity means, so I'm going to plug in. So y is equals to 2 by 3 tan 3 over e cube and minus 3 over e to 2 times to infinity plus 1. Do you know, student, very interesting part. In infinity multiply with any number, it remains infinity. If I add something infinity, it remains infinity. But interesting part, something by infinity, a by infinity is 0. But if I bring 0 there, infinity down, so something by 0 is infinity. Okay, sorry, I just have to explain in reverse order. Wait a minute. Something by 0 is infinity. So this is the whole. But if I bring infinity down and 0 there, so something by infinity is 0. So infinity came in denominator, so let's start. So I can write it now, 2 by 3 tan of 3 over e cube. And this is infinity completely. So 3 by infinity will give us 0. So finally, I got 2 by 3. He is asking us exact answer. So 3 over e to power 3. This is the exact answer he was asking from us. So alhamdulillah rabbil alameen, the question is completely clear.